Oh, you're not. Okay. Hey, everybody. Today is the 2nd of May, and we have Deep Dallas Personal Robotics Group Builders Night online again. We'll do the usual, go around the table. Tonight, we have Q started of Doug D. Ray, who I sense has a couple of things to share, question follow through and discussion and maybe his platform. I have an amusing thing noticed on the news to share. Mike W. has a question or a comment, then we have open mic. So with that, Doug D., what do you have tonight?
So, as y'all may remember, I'm working on my steampunk robot. And for those that weren't here last week, aka Carl, my wife is helping me with the design. And she found this box, which is very similar to the one I was going to make out of balsa wood. And it looks more steampunkish. So this is the body of RoboDog or Dogbot or whatever I call it. And it opens up and has room for stuff. And then she came up with this for the head, 2 little pots. And I'm going to put the standard SR04 sensor for eyes there. Probably put a camera in the nose and whatever. Come up with something there. So that's what she's done for that. And no stars.
Or something. Those look pretty cool, Doug.
It will be cool. She's got a lot of good ideas. I've been focused on how do I get the legs to turn and all this stuff. She says, well, you got to think about the looks too. So she's been really working on the looks. So I have an assistant robot builder. And right here on this table in front of me, it's going to be real hard for y'all to see. And I can't get it any closer because it's just a pile of wires and junk. But I actually got my Arduino hooked to an L298N. And here's 2 of my motors. One of them has a wheel on it. And this is my Ryobi battery, which I'm going to stick in there and lighten everything up. And there's all kinds of hot things here I don't want to touch. But what I will touch is you can't see it because I don't have it locked down, but the wheel is spinning. So, yay, I figured out how to make the motors work. So I have to do that times 2, one for the front, one for the back. And then I have to do it a 3rd time for the smaller gear motors that's going to be used to raise and lower the legs. So all of that means I think I'm going to pull this off because that was the part that's always been giving me trouble when I tried to build my own robot. Nice. It's actually working, so I'm happy about that. The problem is I keep getting too busy to actually do something. I'm hoping now tomorrow I won't have time. I got to go over to the daughter's and son-in-law's house and help them dig a post hole. So sometime maybe before next Tuesday, I'm actually going to put something in that box and screw it down. We'll see. Making progress. So that was it. I'm willing to take questions, but there's probably nothing to really ask at this point. Still a wooden bot.
How many style points are you trying to earn? Because that's going to be something else.
It's going to be something else. I think it's a very ambitious plan for somebody that's never built a robot. That's what I keep saying. And it's going to be, my wife is going to be surprised if it actually works. And I was going to be a little bit surprised, but the wheels roll. And if the wheels roll, I can do the controlling part. As long as I can make the wheels roll. I doubt if I will get the encoders connected. All my motors have encoders, but I probably won't even bother with that right now because that's just a lot of wires on that poor Mega. And I don't think I'll be able to work it out. But I can make it. Oh, I forgot to mention. I've decided on an armband with a telephone on it. So then I don't want to use object avoidance. I want the robot to be able to be object avoidance and just do some things. I want it to be voice controlled. I'll say, follow me, and it follows me. But I also want to be able to say, oh, look here. And there it goes. And last week they talked me into using Bluetooth instead of Wi-Fi for that because I'll be out in the street in Galveston and, there may or may not be any Wi-Fi, even if it's there with 10,000 people. You may not have any.
So I might have missed it, but do you have a name for this robot?
I've been calling it RoboDog, but I thought lately I might call it Dogbot. I don't really have a name. My wife is so good with design type things. She'll come up with a more clever name probably. It can't be K9. I said, well, Doctor Who had K9. And she says, oh, you don't do something like that. Well, we'll see.
Yep.
There's time yet. I don't have to have it operational until December, but I might have it demonstrable by October when we go to something in October. We'll see.
Well,
Maybe you
I
could
was
do
wondering,
K10, one better than K9.
yeah, I was wondering why don't you use servos for putting the legs up and down instead of a motor?
I considered that. I thought that it would take a lot of torque, and I thought the servos, I'm not good with mechanics, so I probably way over engineered this and got servos that could lift me up to make sure I could lift the legs up. I haven't computed the weight yet. I'm hoping to be 20 pounds or less. It could be a little more. These motors are pretty darn heavy, and there's 6 of those in there, and then there's lots of other things in there. There's 2 Ryobi batteries, so it all adds up. Those I didn't show them this week, but I showed them last week. Those little pretend battery things I had. Those are water bottles. That's a good 3 or 4 pounds there with the stuff that's in them. So the whole thing's going to add up. I'm a little worried about it, but I'm just going to do my exercises and buck through it.
I would recommend building in a remote control so you can drive it around, because
Right.
you get
That's what I'm
tired of
gonna
going
do.
over and picking up a 30-pound robot and moving it.
Right. I'm going to do that. I bought a leather armband this weekend, and I'm going to put a phone on there, which will have Bluetooth control to the robot and be able to drive it around. I think that'll look kind of cool.
You just need to go to Goodwill like Ray and get a used land speeder.
I've
Take out
been
its
to
anti-grav
3
and
Goodwills.
go.
I've been to 3 Goodwills. I haven't found anything. I'm not going to the one Ray goes to.
Surely one of them will have an anti-grav unit you can use.
That'd be nice. I intended originally in my design was to have a strap that was controlled by one of those gear motors that would lower the thing, and then I could unhook the strap, and then when he comes back, I could hook the strap to it and raise it back up. But those gear motors are not very fast. It's like 55 revolutions per minute on a 1-inch spindle. It could take 1 to 2 minutes for it to raise. That's
Oh yeah.
not acceptable. So I'm going to get my wife to just pick it up and put it down and put it back on or whatever.
I don't know if he still has it, but I think Kareem had from one of the contests, the robot actually had to lower itself down. So he had some sort of mechanism to bring it down, but I don't know how much time it took to do that. So,
Right.
And if you wanted it to raise itself back up, that's the hard part. Lowering it is,
Yeah, you're talking weight.
yeah.
That's what I'm worried about with those legs. When I get down there and the legs are like this, and I want the front legs to lower and then the back legs to lower, that's got to be able to push against some weight. So
Yep.
that's why I got these really big motors, and they're made to lift some pretty good blinds and things. So I think they should be able to handle the weight.
Yep.
They're just a little slow, but it won't take too long to do half a revolution on the leg or a quarter revolution on the legs.
Mm-hmm.
I'm hoping. My biggest fear is that when they get rolling, they're just not going to go fast enough to keep up with me on walking speed. We'll see. I'm thinking if I can get this back off of there. This wheel is probably a 4-inch wheel, maybe a little bigger. I'm thinking 55 revolutions of this in 1 minute. How far will that go? I could do the math, but I'm not going to. It'll scare me with the answer. But that should be able to keep up with me walking, especially in a crowd where you got to walk a little slower. You're not walking full speed. I'm going to pull this battery out of there so I don't do anything stupid and touch the wrong thing while I got all that hot wires through there. Because all that's just laying out there on that table. I did that to a car once. I had a 57 Chevy. I put tail lights in the back. Off track here. But my tail lights were out and I knew nothing about cars. So I could run a wire with some more lights. I had a toggle switch. But unfortunately, I never really taped off the other side of the toggle that had a blue wire. I call it my kill switch because one time I accidentally, it was one of the toggles that was off in the middle and did something both ways, and I never flipped it up. I always flipped it down. Well, one time I accidentally flipped it because I shorted out everything. Fortunately, it was a 57 Chevy, and I flipped it back down and it started up again, but it was a kill switch. I won't tell you the rest of those stories. Young days. Next.
All righty. Well, that's cool. All right. So then, Ray, I think you are next in line.
Sure.
Remember, you had a find and a question.
Whoops.
Or discussion.
Just a question, and Scott probably knows the answer already, but okay.
Because there's a handful now online who haven't seen your latest find if you wanted to show it again.
Okay.
Yeah.
Let's see, David Anderson's website. Oh, I thought I already had this up. Oh, there it is. Okay. Oops. Further. Yeah. No, that's basic odometry. Yeah, I thought these were actually like the, a delta reading for left encoder and right encoder on basic odometry. At least as far as I can tell, that's what it is, because it looks like he does, well, actually he does this one for, to allow for differences between the two wheels. So you have a left counts per inch and a right counts per inch if your wheels are a little different. But I thought this left encoder and right encoder were actually, kind of a delta, not an absolute reading of the encoder. And the reason why is because he's got, for the theta plus equals. So the kind of assuming that it's like individual small vectors that he keeps adding together, like, you would in like for electric circuits, maybe the two voltages that add up to a larger voltage or something, but aren't necessarily in phase with each other. And the same thing here, that this is an accumulated X and Y. So Scott, do you agree? Do you think this is like a delta reading for encoders up here?
Yeah, if you scroll back up to where he's doing you see the last bit here on a since last sample, right? That's telling you that that's the delta. In other words, the left encoder counts are the encoder counts during this period.
Yeah.
And right encoder is the same thing. The real trick here is that these periods are the same, right? Because if your periods vary, you need something that's deterministic, that this is going to be sampled at a very set rate, so that as you accumulate distances, right, that once you look at the velocity part of it, right, and I can show you, maybe my code is a little bit more complete because David was just kind of putting some of the samples in there. I'll share if you want, and
sure.
I'll show you.
Go ahead. Anyway, that's what it looked like to me. It doesn't specifically say that, but yeah, and I don't know if he actually, maybe in one of his, Saturday presentations, he did show it in more detail, the actual code. But,
it was just kind of a sample, and this is basically my implementation, right? So this function gets called every 50 milliseconds, which is the same update rate as my PID. And
Can
that's
you make that
really
bigger?
important, so that your velocity, because I also pull velocity out of this.
Yeah.
And that's important as far as your motor control, right?
Mm-hmm.
That this is at a given rate, and it's in the same sequence as your PID loop. And basically what you're talking about is right here, where I get the encoder count from my encoder module, and this is the current count, right? So this is an accumulated count. And I store it. I have this wheel object that I have that has a number of different properties in it that I keep track of, like a left wheel and a right wheel. And so here's where I get this particular count, and that's the count I just read versus the last count.
Can you make that any bigger?
Sure, I guess.
Very small, at least on my screen.
How's that?
A little better. There you go.
So now I basically, store the last count, and now I'm calculating how many inches each wheel has gone, right? And that I think part of David's code was like counts per inch for each wheel, and this kind of accounts for different size diameter wheels, right? And you're talking about very minute differences, like on CanMan, this counts per inch is like 700-800, right? And the difference between left and right is about 10 or 15.
Oh wow, you really have that much of a difference? So is that like?
Well, that's less than 1% of 700, right? I mean.
Oh, okay.
And then, of course, you're looking at the distance that the robot has traveled, right? So you take the two distances and you divide it by 2. So if you're like rotating in a circle, right? So right inches may be -1 and left inches may be +1. So basically your distance, it comes out to 0, right? Because these are bipolar numbers, right? These are signed integers. Actually, if you look up here, they're floats. And then basically I use this function both not only for odometry, but also when I'm integrating my IMU, right? So when I have just an IMU that doesn't have the magnetic part or the compass turned on, then I basically say, okay, this is my base heading. Where did I start from? Where am I at right now? And the yaw comes out in 0 to 365 or 369 degree or 59 degrees.
59, yeah. So
this clip heading function turns it into -180 and +180. So that's where I'm at now. And then I calculate and I keep track of the theta, which is actually used in the target location, right? And it's in radian. And so the heading is in degrees and theta is in radians, right? Because when you're doing your sines and cosines,
it's got to be in radians, yeah.
X and Y calculations, they're in radians, right? So that's why I go ahead and store it in radians as well.
Yep.
And then I have a couple of different options here where I tried to kind of integrate both the IMU and the odometry, and I never quite got that working right. But if you're just using odometry, then you would do something like this, because your theta, which is in radians, is the difference of how far you travel divided by the wheelbase. And this is another value that you really have to look at from your platform. In other words, how far apart are the wheels? So as I'm calculating this value, right, what does an inch mean? In other words, that's kind of the circumference of the circle that you're going to be going as you're rotating around.
Like, for rotation in place. Yeah.
Right.
Yeah.
So, and if you notice, this is an accumulation, right?
Right.
And then this right here, it simply rolls over. So 2 pi, this is what makes it, not accumulate to above 360 or whatever it is, 2 point whatever radians per degree, right? So that's basically this is basically just rolling it over as you're continuing to rotate. And then that's converted into degrees to go back into the heading.
Right.
So then you come down here and you clip that so your heading is both 180 minus 180 for left and right. Same thing with the location theta. And some of this is just because up here, it may not have got set. So then this is where the real rubber meets the road, right? The sine of your angle times your distance gives you your X increment. If you
Mhm.
notice, that's an increment of where you were before,
Right.
right? And the same thing with your Y coordinate. So once you've calculated where you're currently at, which is what this does,
Mhm.
you go and you say, okay, I'm going to pass that in and I'm going to locate my target. And then, and this is, again, this is all David's framework, right? This is just kind of my
Mhm.
application of it. So
Yeah.
when you
Interpretation.
locate the target, you know, basically the math kind of makes your head hurt. And I never have quite figured out why you have to subtract 90 from the angle.
Oh, yeah, it's kind of like the front of the robot. If you know, you kind of think of the two wheels, um, that that angle, you're more concerned about straight in front of you, but the kind of the frame of reference, if you don't say 90 minus something, is kind of a, you know, a line across the front of your robot and what angle it's sitting at. So if you're, you know, you're just like, if your left and right counts are just a little bit different, you know, that moves the front of it. But if you're really wanting to find out, you know, kind of the angle that your robot is pointing to, you've got to subtract, you know, that from 90. So
Well, yeah, what you're talking about,
It just rotates it out. Yeah.
and this is of course a differential drive, right? So
right,
when you start out at 0, right? You're talking about 0 between your two wheels.
the two wheels,
Whereas,
right,
like you're saying, your point of reference really is what's in front of me.
straight in front of
I
you.
want to
Yeah,
know which direction I'm pointing, and that's 90 degrees from the angle of your two wheels, right?
that's right. Yeah, Yep.
So that's what you're trying to say. But it just, when you really think about the math, it just seems really strange that you would have to do that.
yeah.
But I can tell you, if you take 90 out, it does not work. So,
No, it'll turn off like to the
right.
right or something.
So this is
Yeah.
basically telling you which heading, and see, I have these what I call like location objects, right? So I
Mhm.
have my location, my target. I think there's a couple more of a reference. I forget now, but so basically now this is what's updating where I'm going, where I need to be, right? So I've passed in where I'm at, and then this target X and Y tells me where I want to be, and then my target heading and distance tells me where I need to go to get there.
Right.
Right. So I use the distance is integrated into like my speed. So if I have a long way to go, then I just ramp up to maximum velocity. And as that distance shortens, then I automatically reduce the velocity based on how far I need to go.
Right.
And of course, my turn, because that's all I really feed the PID is the speed I want to go and the direction I want to be heading when I go there.
Yeah.
And so basically, my location versus target heading tells me what the error is in which way I need to turn. So that ends up being your turn value that I feed into my direction PID. In other words, I need my turn error is the difference between my current heading and my target heading.
Right.
Yep. So that way, once I feed that error into my PID, which handles my turning, then the PID handles the ramp up and the saturation of it, and also the slow down when you get close to your target.
Yep.
So you don't overshoot too bad.
Did you ever consider like rotating first and then traveling like in a straight line to that point, or did you?
Well, you're always going to be dynamically updating that. I mean, you've seen
right.
Can Man or even Burp. I have an action that is, I call it rotate in place, right? So you're basically just rotating to the target, and not creating any forward velocity. I mean, I think Pat, we were talking about that a couple of weeks ago, right?
Yeah.
Rotational velocity versus your linear velocity.
Yeah. Okay. Yeah, there was, it seemed like you could do that. I don't know if it would make it move more accurately because I'm sure if your rotation is just a little bit off, and you have quite a ways to go, say, you're at one end of the course and you want to get to the other end of the course.
Well, yeah, you typically I see that you overshoot that. And then when if you're stationary and you rotate to a target, and that may be up to 180 degrees one way or another, right? So when you reach the threshold and you say, okay, I'm lined sufficiently, which in my logic is about 3 or 4 degrees, it's not perfect,
right?
And then you give it some forward velocity. You normally see the thing correct, but this is also going to correct you as you're making small corrections. Like for instance, an outdoor, for the outdoor robots, as you might drift off from the heading, that pulls you back in, right?
Right. Because it's always calculating basically another heading and distance to get to,
right?
Whatever your update rate is.
Right. Yeah. I mean, for instance, if you go over here, and this is where I create tasks. Let me see if I can find it. For instance, like a navigate task, right? This is how I navigate. And if you look here, I take the target distance and then the target heading, right? And I kind of scale it. This is an internal variable. So I create this heading error and a distance for this particular behavior, right? Mm-hmm. And so this is also David's architecture of supposition, right? Mm-hmm. So you have these structures, and it's an array of behaviors. That's what BA stands for, is behavior. So on the behavior of navigate, it's going to set its variables, and it's basically, kind of, again, I look at the distance and am I close enough to the target and things like that. But ultimately, this is the flag that gives the arbitrator that says, okay, this behavior should be active or inactive. Like for instance here, that's what gets returned. So when you're not, where is it? I guess I don't see where the navigate flag gets set to true somewhere else. And then basically it gets set false here once you've satisfied that you found it. So this is kind of how you use these target distances and target heading to kind of integrate into your logic of how you would follow something or how you would basically navigate to a particular target.
Mm-hmm. Okay.
And like I said, this is just a singular task. I have a lot of other tasks, and some of it's commented out, but like you're roaming around or obstacle avoidance, that's where you put that kind of logic. Like here, this is where I locate the cone. So basically, I pulled this code from Belch, and this is my new robot that doesn't have a lot of sensors. So, but you can kind of get the idea of how you would segment it. And this is an align task that I had to align to a wall. So that's the kind of thing where you would, and again, you'd see is basically kind of parameters that you set. And then the arbitrator goes through this array, this BA array, and says, okay, who's got the highest priority and who should be controlling the motors and what the robot's doing right now at this very instant, right? So, and again, that's all kind of part of that paper that David published and gosh, that was years ago. He put that together, and it's really good because, I mean, it handles all the math. You know, it tells you the math, even if you don't really fully understand it, because actually the GPS math is just beyond what you would think, right? I mean,
thank God he did all that hard work for us.
Oh man, well, there's actually a bug in his GPS stuff. I don't know if he ever corrected it on his website.
Oh,
I don't
okay.
remember the details now, but it was very difficult to overcome.
Yeah, I may have kind of stumbled on the same thing. I looked at his code, tried to implement it, and it wasn't giving me you know, the correct angle. And I found some other code that did. It was a little bit different. And I told him about it, but you know, he said his code is working fine, you know, for in his robots. So I, you know, I don't know if it was a, you know, translation of, you know, what I saw in, you know, in his material, but I did find something else that worked. It, you know, it kind of got to the same results for, you know, what your heading should be.
You really got to be careful about the floats and the sizing. I think a lot of what David originally wrote on that 6800 that he was working with, or 68K, whatever derivative it was, a lot of the values I think were 16 bits. It seemed like I had problems with the signing and the sizing, because I think he was using doubles in a lot of areas. And again, I don't remember all the details. I mean, you know, that was too many beers ago, I guess I would say.
Yep. Okay.
But, you know, I mean, it's like any other code you download off the internet, right? You use it with some caution.
Oh, yeah. Yeah, you get what you pay for. No doubt. Yeah, he never did. He did respond back, but he said it, you know, his code was still working for him. So I don't know.
As any programmer would say.
Yep.
Hey, it worked on my bench. I don't know what you're doing wrong, because it worked great for me.
Yeah. So, yeah, you know, I found something else and got it to work. So, and you know, it's yeah, the nautical miles crap is, you know, and whatever other units go into it, you know, it's kind of like, okay, it's the curvature of the Earth, but you know, the Earth really isn't quite a sphere. It's kind of like a squished sphere, you know, or
well, you know, that basically the way you calculate it is you're calculating the angle of the difference of the angle from the center of the Earth, right?
Mm-hmm.
So if you think about how small that angle is for the circumference of the Earth, I was thinking, man, there's got to be an easier way to do this, but I guess that's what accounts for the differences in the curvature of the Earth or whatever. I mean, I can bring that code up too, and you know, if you want some brain damage, that's fine with me.
Nah, that's okay. You probably have enough of that.
But yeah, you know, I struggled to make that work accurately. And again, I don't remember what the math error was. It was a simple little something. I don't recall now. I'd have to compare it, but you know, I mean, you know, I can't knock David's code, because I mean, it gave you a really good foundation to start with.
Oh yeah, yeah.
And it's really pretty cleanly put together, especially the way his supposition, which is a little bit different than his odometry stuff. I expanded on that quite a bit with the structures that I use. But it's still the same basic framework that he proposed and he put together. So yeah, I mean, it was very helpful. And you know, I mean, if you find some good code, whether it works perfectly or not, then you know, there's no reason not to start with that. A lot easier than starting with a blank screen, that's for sure.
Okay. Well, thank you. Somebody's measuring something. Here, the tape measure.
Cool. Yeah, Ray, did you want to show your did you want to show your platform again, or should we move on?
Yeah, I could show it if you want to see it. This is another Goodwill find. It's a pretty good sized rock crawler. It's 4-wheel drive and just 2-wheel steering, and it was $4.99. So it's got, the wheels are, I think, just about 6 inches in diameter, and so it's actually a little over 6, maybe 6.5. And I thought for an ultra cheap outdoor platform might work pretty good. So anyway, if it's over $4.99, I just don't buy it at the Goodwill. So
We all have our limits.
yep.
Okay,
No,
cool.
I've actually bought some things that are a little over that, but I found some pretty good buys. I got the first hoverboard, I think, for
So do you know what the brand is on that vehicle?
say it again.
Do you know what the brand is on your rock crawler?
No, I don't. It says Diamond X is the, or Polaris maybe. Yeah, I don't see any other labels.
Yeah, generic.
Yeah. What would a brand name be?
New Bright, maybe? Ed was asking.
Yeah, I don't see anything that says New Bright, but anyway, this one hoverboard was $8.99, and the other one was I think a little bit less. I think $6.99. So it's been pretty good. I actually found I should have bought it at the time. It was you actually attach it to the hoverboard, and it's got like skid steer controls, and it actually tilted the two sides of the thing, so you could basically put this thing on your hoverboard. It had one caster in the front and a place to put your feet and a seat, and with the 2 levers you could control the motion of the hoverboard. And it was like $14.99. I should have grabbed it while I had the chance, but
You can build it if you want to. Instructables has an article on that.
oh yeah, there's all kinds of videos
That
of
is pretty good.
old farts, moving around on their hoverboard thing, not breaking their necks or bones falling off just a plain hoverboard, So, anyway, cheap entertainment. It's kind of fun to go there and rummage through other people's junk.
Add it to your own hoard.
What's that?
And add it to your own hoard.
Yes.
Yes.
Add it to your own hoard.
Okay, cool. Well, we look forward to seeing that. Okay, I think I'm next in queue, then Mike W. Then we have probably we should talk briefly about the contest after that, and then open mic. So the first thing I have is a bit of a current events piece, and I got the link in here, but it was an interesting article. Apparently there have been, with San Francisco allowing self-driving cars with like nobody physically in the car, they're starting to experience issues. And if you follow the link I just pasted, somewhere in here, the body cam footage shows that they had set up like there was an explosion. So they had fire trucks. They had this probably 2 or 3 inch fire hose drug across the street, and they couldn't figure out how to stop this Waymo car from trying to drive across the fire hose. The guy at one point he pulls out this, I think I'll just get a flare. So he got a flare and he lit it up and he pointed at it and he said, "Stop!" Like it's a dog or something. It's like, But think about it. What could you do, right? I mean, maybe grab a blanket and throw it over the sensors. But that doesn't work if it's microwave.
Aim the fire hose at it.
What's busy taking care of the fire? I mean,
Yeah.
and it might just think it's rain. More gas. It's not going fast enough. So aside from having somebody stand in front of it, which it seemed to respect, it was only after he put the flare down and walked away they said, "Okay, smoke. I'm going to go ahead."
What's wrong with firing a gun at it?
Well, this article hints apparently somewhere in here there's a map of all these different incidents around town, and like this one shows the actual fire hose, but apparently they've had cases where they've had to break into the car and do damage to it to try and stop them from things like this. Get control of the people that are supposed to be monitoring it.
Yeah, there should be a spot, like a disable button or an emergency stop on the side of the car to when there's an issue.
Yeah, something like that.
Big red button on the roof, just.
Yeah, right on the hood where it hits the people that are crossing the road.
Big red button. Don't let it go faster than you can walk. They haven't listened to DPRG. What's wrong with them?
Yeah.
Okay, well that's all I have. It's a fun little thing to read and watch. So there you go. And with that, I pass the baton to Mike W. You're next in queue, I think.
Yeah, so you saw my little robot toy, and it does like Cartesian coordinates instead of polar coordinates. And but I do have the sonars will seek out in a polar form, and so there's some trigonometry to determine the distance to the object relative to the front bumper of the car, not from the sensor. So, and then I have two sensors on each side, and looking straight forward, it combines them into one sensor, so it can actually see a cannon straight ahead and get a relatively good idea where it's at. But I was having trouble with my sensors because my iPad battery I have is like 6 volts to 7 volts, and my electronics is 3.3 volts. So the little computer board I have has this regulator, and the HC SR04s I bought earlier, would not work at 3.3 volts. So I was running them at 6 to 7 volts, and they worked. And then I needed another sensor, so I bought more sensors. I bought a package of 5. Like, oh, that's a good deal. And I think that's when it stopped working at 7 volts. It would sort of lock up, and I could only run it at 5 volts. And that's why I had that weird battery on the back. And it was like a 3.5 to 5 volt range instead of 5 volt to whatever for the really old CMOS chip. And then I realized when I was trying to debug it, since I want to start working on my battery again, my wheel battery, not this extra battery, I realized that one of my sensors worked at 3 volts. I was just trying to figure out what to do. And then I looked at it a little closer, and they were different. There's some SR04 sensors that work at 3 volts, and they have an I2C interface built into them. And they're a newer design. So those wouldn't work at 7 volts, and that was causing it to fail earlier. So I just replaced all my sensors to 3.3 volts, the new sensors, and at least I'm going forward again. Yeah. So right now I'm doing a step back and say, okay, I threw sensors on, gave them jobs they weren't originally expected to do, and they sort of worked. Now I'm going back and carefully understanding them and calibrating them so that they work well instead of sort of work. That's what I've been doing, and it's going to help a lot.
That's good. So are you running all those sensors off the little regulator on the processor board?
Yeah, the 3.3 volt. Yeah, and the servo controller. and a voltage monitor controller.
Okay.
So they're all little, the sensors. So yeah, they're pretty low power, especially 3.3 volt, newer technology.
Oh, okay. Yeah, you might want to look at it and see if it's sagging or touch it and see if it's getting a little too warm.
Yeah, it's 3.27 volts. Yeah.
Yeah. Yeah. Have you looked at it with a scope? Is it, like when things turn on, do you see a dip in it or noise or?
Nothing really turns on. I guess the only thing that would quote turn on would be the when you turn on the sonar transmitter.
Right.
Yeah.
Yeah, that can be a thing. I think it's kind of nice about these kind of motor drivers like the RoboClaws. They actually have a battery eliminator circuit on it, so you can. I think this one it's good for like 5 amps at 3 volts, so or vice versa, 5 volts at 3 amps. What I meant to say.
Well, I have my motorboard servo is a servo controller. It's a 16-channel servo controller, and its electronics is 3 volts on I2C.
Right.
Of course, the motor is 6 to 7 volts, and my wheel motors are converted servos that run 360 using that controller.
Mm-hmm.
Yeah.
Yeah, I noticed the regulator on the ESP32 boards they don't seem that great. I don't know if they're a cheap knockoff. I think it's a 1117, and some of them work at, produce 5 volts, others produce 3.3, but they're all linear regulators. And it kind of wanders, like maybe 1/10 of a volt, and depending on what's being, what's going on in the code. And
Right.
I was just a little surprised at that. I thought it would be a little better, but
I don't think the sonar sensors are that sensitive to voltage. The only thing that they would be sensitive to is range versus voltage, not distance. This is basically the speed of sound and air. So, but yeah.
The ultrasonics do have an impact on voltage that you feed them. For example, if you feed them a 3 volt signal as opposed to a 5 volt signal, on some of the sensors, the range will go down.
Right.
The pulse is generated by essentially an RS-232 converter chip. And so it's got like a couple of voltage doublers in it that when it pings, it really slams a high voltage into the transmitter module. So the higher the voltage, the more coaching you get within the boundaries of that RS-232 chip. It's a Maxim, but I don't remember the model.
Yeah, so voltage affects the range, but doesn't affect the distance, the accuracy.
No, it shouldn't affect the accuracy.
Yeah, there might be a secondary effect, but it's definitely not a primary effect.
No.
So is that what I guess makes the piezo element ring? You put a spike of voltage on it and boing. Or is it broadcast, or is it, is there like a square wave that goes in at a certain frequency that
Yeah, I think it's a square wave at a certain
it is
frequency.
a square wave? Okay.
Yeah. Well, I mean, I don't know if you put it on a scope. I've actually done that, but I can't remember whether it was kind of rounded on the top or truly square.
Oh, okay.
Yeah.
Yeah.
I'll see if I can find that real quick.
But the really cool thing is, I got those new ones really cheap, and I didn't know they were different. Yeah, and I was really pleased that they were 3.3 volts.
Mm-hmm.
That's good.
So that's cool. All right. So next, should we spend a few moments on the contest? From what I understand, we have a practice session coming up on this Sunday, the 7th. Doug, are you thinking the same times, or do we need to ask?
Yeah, I set it for 10 to 3.
10 to 3, okay.
10 to 3. And it took us about 30 to 45 minutes to set things up. But everybody's seen it now, so it shouldn't take as long.
Okay.
You know. Yeah.
I plan to pick up the arena, the new arena from Scott, and bring that there. I won't be able to stay the whole time.
Is it Saturday? Saturday?
Yeah.
No. Sunday.
No, Sunday. I'm sorry, Harold. It's Sunday.
Sunday.
Did I say Saturday? I didn't mean to. If I did,
I didn't hear either way. I had to walk out of the room, talking to the wife, all those sorts of things.
Mhm.
So I was clarifying.
Yeah.
And then the competition is Saturday the 13th.
And then next week, the 13th is the actual thing, and that's all day. And I think if you look at it, I think we allow kind of a break around lunchtime so that we can get started. I think I don't know. You'd have to look at the schedule. It's on the website.
Okay, I'll put a link in here in just a minute. Yeah, there it is. Okay. All right. Okay. Well, are there any other? And it was Mike or somebody. I was interrupting what you were saying. Is there something else to talk about for the contest? Okay.
So, Scott, are you still off for this contest?
Yep.
Oh, dang.
Yeah. My mom's still turning 80.
Okay. Oh, that's right. I knew it was a reason, but I didn't know it was that.
It's a great reason.
Well, you ought to ask her. Does she really want her birthday? Does she really want to turn 80?
I'm kind of appreciating Scott's generous offer to allow somebody else to win this year. So I'm really appreciating that.
I think Scott's mom would like to celebrate with DPRG.
Yeah.
We think get her a cake if she.
Tell her we'll buy her own pizza.
I'll let her know.
Get her pom-poms for Scott.
Yeah.
As he trash talks Ray again.
Yeah. Well, I'm just curious who Ray's going to come in second to.
I don't know. Mike is being pretty strong out there.
Yeah.
Let me put it this way.
I think's got a chance of kicking your ass there, Scott.
If Ray starts losing bolts on it and heads for the wrong goal again, Mike will take them.
It could happen.
I'm going to wear my favorite orange shirt. So
I think it's a lot more important to Scott than it is to me, though. So
I don't know.
I
don't know, Ray.
I don't care which place I take as long as you're behind me.
Ooh. Well, we can run our,
we can have a smackdown on another day.
No, you could. You don't even have to come in. You could just run your thing, and it's just your time. What's your total time to run the course? So, a short video, and we could, somebody could come in and
Ray,
beat your record at any time.
Well, I'll tell you what. Here's something we could do. Scott could compete his 3 runs this Sunday, if he wanted to.
Sunday,
yeah, and then they would stand, and then that would be the new bar, and everybody would have a week to figure it out if they can get it better.
Yeah, but you smoked your motors, didn't you, Scott? Is that?
No, that was my new robot, but no, they're not. I didn't let all of the magic smoke out, so they're okay.
Oh, really?
So, Scott, I'm serious. If you want to run this Sunday, see your new course in action. You don't have to stay the whole 10 to 3. You could come on in and say, okay, I'm ready to run my 3 runs. Ching, ching, ching. Pat, are you going to be ready to run?
And leave 3 minutes later.
Yeah.
Unfortunately, I will not be able to enter the contest.
Okay.
I've had a number of setbacks, and I just don't have enough time to get this going.
Gotcha. Okay.
I'm actually very disappointed in myself in I thought I had enough time, and just life got in the way. And
Doesn't it always?
Doesn't it always? Yeah.
Mm-mm.
And unfortunately, I just found out today. We just picked up another 2 contracts that I'm working on.
Oh, you're gonna have to go make money, some more money, Pat.
Well, I work 600 or 700 hours a year. That's about it. But it's been January was busy. Like the fall was busy. January was busy, but it's been pretty quiet since.
Okay.
And I just found out confirmed today that we're pretty much got 2 more contracts that I'm involved in, and so my 2 months vacation out west is going to be a working vacation.
Oh well.
So, but it is what we do. It's how we pay for things, and hopefully a trip to Texas this fall for a contest.
Ooh, that'd be cool.
I'd really like to go. And I think I'm going to change my efforts for whatever I got for robot programming to the fall contest.
Yeah, I know what you mean, and it will be here before you know it.
Well, exactly. So if you guys are having it again in November, it would be. It gives me time, but
we'll have to check with Steve to see what he wants to do.
Okay.
Yeah, because he's got some things that he doesn't like to do around. So we'll find out what's going to happen.
Yeah, well, I'm aiming for sort of that time of year, September, October, November, and
yeah,
I'm bringing robots with me out west, so I'll have that to do. But I've got work to do as well to help pay the bills.
Yeah.
So I've been disappointed in myself for not getting a robot.
So Pat, is there any effort to manage, I think the forests in like the northern US and I think a lot of Canada is kind of like I think it's like one of the last big forests that are out there, since they're making inroads into the, Brazil and the Amazon.
I could tell you this, most forests in Canada are owned by the Crown, so by the Canadian government, the provincial government. So whereas in the U.S., most of the land is privately owned.
Yeah.
So where people will sell off and, okay, hey, come cut my trees. And it's up to the owner to replant or whatever he deals
or not, yeah.
Canadian forestry industry is owned by, most of the forest is owned by the Crown government. So people have Crown rights. So the argument we get into the U.S., you've heard of the softwood tariffs. In Canada, the forest is owned by the Canadian government, but essentially managed by whoever owns that chunk, whoever owns the stakes to that forest on that chunk of land. So you can manage it yourself, or you can get the government to manage it for you. The government managing it for you will be much more expensive. So most forest industries are self-managed, and essentially most of them, I would say virtually all of them, are cut a tree, plant a tree, one way or another. So there's a lot of research that goes into how to cut a boreal forest and how to grow a boreal forest as opposed to a white pine forest or whatever.
Right.
Which is what they used to do in the past. So they would cut a boreal forest and plant a white pine forest. So there's been 30, 40, 50 years now on essentially cutting a forest and regrowing a boreal forest, and it's working quite well. It's working actually much better than the planted forests were.
Yeah, I think I was really surprised to see it in Oklahoma. Yeah, a lot of the land was, or the trees were cut down on the land, and one species, it looks like, was replanted.
Yeah.
And
that was the traditional way for most Canadian companies. And that was in the late 80s, early 90s, most of them had ditched it to what was the latest, greatest, which was managing the forest at an earlier stage than planting. So it's essentially how you're cutting, what you're leaving behind, how you're monitoring, because there is monitoring. You just don't walk away and never go back. So they monitor it. One of the reasons I know this is I did the last 20 years of my career in forestry, basically in sawmills, and they're doing quite well. So what we're seeing happened in the late 80s, early 90s, they're getting ready to cut again. So they have a boreal forest grown up, 45-year-old trees, and they're close to harvest, 45 to 65 years old.
Huh.
Incidentally, in Canada, we cut less than 1%. It's way less. It's like 0.1% of the trees every year. So it's very much sustainable, well over 100 years.
Well, that's good.
Yeah. That's just my forestry bit. That's, like I say, I did the last 20 years in forestry.
Yeah.
Lately, I'm into everything. I'm into plywood. I'm into cement. I'm into all sorts of different things. Not robots, unfortunately. So my 6-can competition, I put off to the side about a week ago. I dropped everything on it, and I was going to say something at the last meeting, but so this meeting, I won't make the contest. I was really looking forward to kicking Scott's butt on it. Obviously, that's not going to work.
It's out there, ready for being kicked. So
I thought the comment of who is Ray going to come in second to was hilarious.
You know, it's going to happen to somebody. It could have been you, Pat.
Oh, I was hoping, but I'm not there. Not that I won't continue, but I think I'm going to put my efforts towards the fall contest starting now and at least hopefully be ready to go. We'll see how that goes.
Well, Doug, aren't we going to have another indoor contest in the fall before Robo Columbus?
It isn't scheduled. I'm open to it. I mean, anytime there's two of us together who want to smack down, I'm all for it.
I was thinking it would be nice to have something in like February, indoors, and everybody's the outdoor contest is done. Everybody's usually it's pretty slack at that time, even at our meetings, and it may generate some interest.
That's like I say, all of these things are somebody say when they want to do it, and we'll set it out and do it. And like, for example, I'm also open, to if we want to, we have some traditional contests because progress is slow, as you see, Pat. You know what I mean? It's slow. So that's why, I've been trying to get my Robo Columbus going now for, I think, 4 years. And I actually got one that got me up to 4 points. And then, it's been downhill ever since then. And so I'd like to get, so you get one chance a year. That's it. If you blow that chance, it's next year.
Yeah.
So, and I keep looking at the number of years I got left. I better get it on. So anyway, or we can, like I said, we can set up that. It was sure fun. I know, Pat, you didn't get into this, but I really enjoyed meeting everybody in person at the practice session. That was a good, we had a lot of people there.
I'll plus one all of that.
Yeah.
I mean, as hot as it was last year with the Columbus thing on the outdoor and all that kind of stuff, that was still a great time hanging out with everybody, in person. It really was. And you get to see a profile of me other than this. I promise you that. So,
well, I could say this. You guys have seen all of the people in the Espanola, Ontario Robotics Club.
We are honored.
It's just me.
That's good. No politics, huh?
No, there's no politics. Who's going to be president? Who's going to be secretary? Luckily enough, when we did the Four Corner, I had my wife help out filming and stuff like that. But it's there's not a lot of people. You guys got something special down there. I know there's a few clubs in the States, Seattle and a couple other places. But you guys have got something special to be able to get together and hold contests and do this. So I'm much appreciative when you guys include remote and keep doing these sessions, even though COVID is over, and you guys keep having these sessions. I'm a huge fan, and I'm going to keep doing it as long as I can.
Yeah, I think it's been a good idea.
You certainly add something, Pat. So it's great to have you on board too.
Thank you.
Scott's got a thumbs up flying across the screen there. That's pretty cool.
I saw that.
Okay. Hey, so next in queue, I think we had Jack and then open mic. So Jack.
Yeah, so it's almost complete to make a chocolate milk right now, but just need a little bit of fine tuning with the press. I'll show you what I've got so far. So right now it's going to grab the cup. I guess
Hey, Jack,
yeah.
I want to make sure that you get properly thanked for your dad, whoever provided the pizza on Sunday.
Oh, yeah.
Thank you very much.
Oh yeah, of course.
Yes, thank you.
He was glad to. So let's grab the cup. Now it's going to add the hypothetical syrup. And then now it's going to mix the hypothetical coffee and syrup.
Jack, are you on campus yet? Is this going to be just part of the aim to get a lot of friends on campus?
No, not yet. So then this is where it dispenses the cap. And that it does very well, finally. But then now is where it gets stuck. Oh, it did it. All right, that worked.
You're not supposed to say it like that, Jack. You got to keep your cool. You just go like, oh,
I've been doing this the whole time.
under your breath, say, "Holy shit, it worked!"
So
Cool.
then,
That's awesome.
The press would come down, but right now I have that turned off.
Okay.
Well,
Jack, my advice, to garner friends in college, it needs to be mixing an alcoholic drink.
Oh, maybe instead of syrup, it will put in some rum or something.
There you go. Some Jack Daniels.
Some fortifier or something.
Yeah.
Yeah. On Sunday, you were looking at that mega robot with the extendable arm.
Yes. Yeah.
Talk about maybe incorporating some of that design in here.
Yeah, I like that idea because I was wanting. So I was thinking about basically raising this up, and then where it would give the cup, it would just come down all the way. But I didn't want this big rail the whole time going from the top to the bottom. So I liked his idea where it was two rails, and then the one through his weird mechanical setup would only come down once you needed it to. So I was thinking about doing something like that. But I was hoping in this summer to start welding a more permanent piece once this is all put together, but we'll see about that.
Mm-hmm.
And then I'd probably implement that part.
Cool.
That's pretty awesome. I
thank
think
you.
that's a gold star, isn't it, everybody? I mean,
Yeah. That sounds good to me. Now, specifically because it made it, right?
Yeah.
Right. Yeah, Jack.
Right.
And
Like it's
what's
been
the official
doing.
name, Jack? Do you have a name for it yet?
I did. I think it was Benji. Yeah, I was going with Benji.
Okay.
Mm-hmm.
Keurig 2.0. There you go.
Mm-hmm.
That was a J-I or a
I'm sorry?
B-E-N-J-I?
Yeah.
Okay.
Mm-hmm.
Okay, we want to use the official name. I called it DrinkBot in a couple things there, so we'll have to
Okay.
have to call it correctly.
All right.
And what's Benji stand for?
Benjamin Franklin.
Okay. All right.
Mm-hmm.
Very nice.
Mm-hmm.
As in the $100 bill?
Yeah.
Yeah.
Okay.
It's a $100 cup of coffee.
Yeah.
Cool.
Mm-hmm.
Well, that takes us to open mic night then. So floor is wide open.
You could like have a name similar, like, to Starbucks, like Starbix or something, and then they would think it was Starbucks, but just a slight misspelling of the.
Doesn't sound that legal, but.
Well, it's not copyright infringement if you don't spell it identical. Yeah. So,
Yeah.
I was going to call my robot Six Pack. Has that been taken?
I don't think so.
Six Pack? No, I don't think so.
Yeah.
I don't know why. That's a very good name. I don't know why it hasn't been taken.
Yeah. We haven't had much trademark infringement in this club. Remarkably, just smack talk. That's all.
Probably because most of the owners don't have a six-pack. So
we're talking about beer. Come on, 6 cans of beer.
Yeah, I know it's natural. Okay, so Mike, you're now named your robot 6 cans, right? No, six pack.
Yeah.
Okay, all right, cool.
Belly up. Somebody suggested belly up. That's great.
There you go.
That's probably more our group.
I just like Mike's Mecanum entry. That's pretty cool how he got that to work so well.
Yeah.
No encoders.
Well, I really like the fact that it's also it's so different from other solutions.
Yeah,
that's really cool. Now, Kareem, how about you? How's it coming, guys? We
want to see some fantastical things here.
Yeah.
Ain't nothing happening here.
Oh.
Well, it's not entirely true. I mean, it got it to recognize cans, but that's the navigation stuff is going to be up to the team.
Okay. All right. So it may happen.
It may happen.
Okay.
Probably a little too little, a little too late.
Yeah, well, you guys are known for your final day,
last
24 hours push.
I don't think they're going to do an all-nighter on this one.
Yeah. It's not the same Gravis as the World, huh?
Not quite. No.
Not quite.
It was fun to see it.
Yeah.
The mega robot.
They won't be enticed by free pizza, you're saying?
No, they get that all the time.
Oh, they do? Nothing special then.
Yeah.
I was a little late joining because I had to drive across Irving to get a new to me Ender 3 of some sort.
Ooh.
How's this for $70?
How did you get it? Harold, was that a deal or was it
Marketplace on Facebook? I've been looking to get some extra stepper motors and stuff and those kinds of things.
Yeah.
And so I see these people sending up in the marketplace going, I don't know if it works. My ex-boyfriend couldn't get it to work. It's been sitting here. I want, $100 for it. I'm like, here, I'll give you 50. Sometimes I'm doing like stupid low stuff.
Yeah.
And finally, this guy rolled up and he wanted 60, 65. The only reason I gave him 70 is because I couldn't break things down to a 5. I couldn't get a 5 anywhere. So I've been just doing stupid low stuff because, one, if you say it doesn't work and you don't know how to fix it, you're getting rid of it, it's worth $50 to me in parts. That's just what it is. Some people say, and nobody's responded to me in a negative fashion. They just haven't responded.
Yeah.
And I'm like, if you think I'm shafting you, well, fine. I can go right now to Micro Center and get a brand new in the box that I get to build myself and screw it up myself for $99 because they got these things for $199 with a $100 coupon if you've not done the Micro Center before. As long as you've got a cell phone they don't know about, then they can get you they send you a coupon to your phone is how they do that control. And as long as you get a cell phone they don't know about, you give you $100 off of one of these Ender 3 printers.
Is that a version 2 or a version 1?
This is a version 1 or a version something. It's an Ender 3 of something.
Okay.
But it's older. The guy had it. I asked him why he got rid of it. It's because he's moving and he hadn't played on it in a very long time. And he's not going to pay to ship this because he's like moving to Alaska or something.
Yeah.
And I said, if I want one, I'll just get another one when I get up there and all that kind of stuff. And
yeah. Does it have the glass plate or the non-glass plate?
this has a, well, stuck down right now. It's a non-glass plate. This has a,
Okay.
magnetic.
Yeah, that's a 1. That's good. That's nice.
Yeah. And
So the ex-boyfriend's not going to come around looking for it, is he?
no, this is a different one. This is
Different one. Okay.
yeah. So I see all
Get a
these
knock on the door. Hey,
I've been just
want
I've
my
been
printer back.
chunking, $50 stupid low at them because I'm like, I need to get rid of this fast. Okay, $50. I'll come pick it up today. I don't hear from them. I guess you don't want to get rid of it that fast,
Mm-hmm.
And I know it's stupid low, but that's what it's worth to me, especially when you say it doesn't work. All right, there's something wrong with it and I can't fix it. Well, I'm not going to fix your craziness. I'm just going to use it for parts. I've got at least one project that could use 3 stepper motors in the queue right now. So, and then I've got these. I got 40 by 40 rails, B stuff, some 20 by 20 by 10 by 20s, and some 10 by 10s. I mean, what I'm looking at between that and my TiVo over here, I bet I could build a robot chassis out of this and slap some wheels and things on it that I got laying around here. That kind of stuff. So just, I don't know what I'm going to do with it, but for that price, I'm not passing it up. I'll drive over to Irving and pick it up and then drive to the house. Yeah. What's funny about this magnetic bed here? The people that started with glass plate think it's an upgrade to go to the magnetic bed, and people that started with the magnetic beds, most of them I talk to, think it's an upgrade to go to the glass plate. So, whatever you go, whichever way you want to go on that way, knock yourself out, right?
Yeah, I've got on mine. On one, I have the magnetic because if you're doing PLA, the magnetic is the way to go. No, there's no competition. But if you're going to do some of the other stuff, you really don't want the temperature is so high that you'll screw up the magnetic plate. So you've got to have
glass.
Well, you don't need glass, but glass usually is what people get. They have some sort of.
There's some stuff out there called G10 that you can get on eBay, not eBay, but Amazon. There's just sheets of that, and a lot of people, like my friend Mike, he has G10 on one side of it, and he's got it bonded to some plate glass on the other. So depending on which surface he cares that he needs, he just flips it over on the thing. And G10 is what makers use. Angus down there in Australia uses all the time for his build surface. And I don't remember exactly where it is, but I've seen it before on the whole deal. And he swears by the G10 stuff. And it's
so
cheap.
What is G10?
I don't know, some kind of thing. Let me see if I can look it up right back.
Circuit boards are made out of.
Just fiberglass circuit board material.
Okay.
Okay, fiberglass circuit board. So already.
So the flexible bed isn't good for ABS because I have a problem where when I'm printing an ABS, it's either glued to the bed to where it will not come off at all, or it just pops off during print, and I can't seem to get anywhere in between. So I was wanting to get the flexible beds that could be glued to the bed, and then when I'm done, I can flex it off, but it doesn't work for ABS.
I don't know.
Uh-huh.
I don't know. Generally with ABS, I've got some ABS around here that I've printed it for years. I just dumped totally out of ABS because I got tired of dealing with that very same thing. Okay. I've got my ABS slurry and all that sort of stuff to get it down to with the acetone and the ABS, and I concentration it, get it sucked down, and that's all wonderful and good. But I don't. In the summer months in my garage, ABS works pretty good because the temperature remains up, right? But if it's anywhere else, and the way people come in, I say people, the wife would come and go and things and that kind of stuff, it just warps too much for me, especially when tough PLA or PLA tough PLA is a pretty good alternative, and it prints like PLA and it bends like ABS, so it's resilient.
I haven't heard of that.
Yeah, they got it at Micro Center.
Okay.
and I always go check that out. That's
Is it good with heat? Because that's my big thing why I was wanting ABS is because it's more heat resilient.
It does print a little hotter, but not ABS hot.
Okay, so it won't melt in the sun if you leave it out.
I have not
work
tried.
in the sun. Okay.
I have not tried.
ABS is more resistant to those kinds of situations. It's one
Then tough PLA.
Yeah.
Okay.
And it doesn't.
Survive an accidental.
It'll give you some tells before it shatters too.
Mhm.
Like it doesn't just all of a sudden,
Okay.
break all over the place. So I find it was pretty good, but we moved entirely to nylon for our robotics parts.
Oh, okay.
It's just so darn tough.
And nylon's not hard to print at all.
It isn't.
Once you get used to it, it's actually pretty good. In fact, I mean, we do have fails every once in a while, but usually it's actually a little bit easier than ABS. I found in terms of once you figure out how to get it to stick to the bed.
Okay. Yeah, that's what I've heard. I've never actually tried to print with nylon. I've just seen people do it and try it and talk about it. And I'm like, I don't have a printer capable of printing nylon anymore.
It does require a much hotter temperature, so you gotta have a good hot end that can do 260, 270, that kind of thing.
PETG is another option.
I'm sorry?
PETG.
Well, I've heard of that, but I don't know much about it.
Yeah, PETG is the same stuff they make the water bottles out of.
Ah.
Okay, they put that. PET is really what they make out of. The G makes it 3D printable, or their formulation for 3D printing, anyways. And it prints. It's a lot more brittle, but it prints in the 240 range, 250 range, just much like ABS. And the biggest printing on that is you have to slow down. It's extra sticky. It's extra sticky. But give it a go. Yeah.
But other than that, prints fairly well. It's not much harder than a PLA.
Yeah, you'll need to spend some time tuning your settings to print PETG. You're just not going to slap it on there. Use your PLA settings with a temperature change. That's not going to work. You need to be a little bit more deliberate with it. But yeah, it prints fine. I've got some around here. In fact, one of the things in my project list that I told not everybody to look at last time was there is a modular hydroponics tower, and it's all, and the guys that are printing that are all in PETG. So I will, depending on if I can make one big enough or small enough for my printer that I have, then I will print some towers, and it'll all be PETG because it's going to be in the sunlight, UV, all those sorts of things that you would expect it to be. And the PETG is actually really, really cool in a lot of ways. It's just like I said before, you're going to want to play with it a little bit before you dial in your profile you use when you're printing it, because it does print a little different. It likes to be sticky.
Okay. Jack, one of the two tricks to ABS, if you wanted to go there. One, you got to keep it in an enclosure.
You do.
You got to keep the air around the print pretty warm. And the reason, or it'll warp.
Okay.
Okay. So, and if you have a ceiling fan, screw it. You're never going to get it right. So you got to have it in an enclosure. And then the second part is you can stick it to a glass bed with those glue sticks.
Yeah, I've got. Well, it's not a glue stick, but it's special 3D printing glue, and that does work well, but a little too well.
Yeah, well, that's what I'm saying. Try glue sticks.
Okay.
Elmer's glue sticks.
Okay.
Yeah, or even the purple ones, which are supposed to be a little less grippy.
Have you tried? I mentioned before an ABS slurry. Have you tried that?
Yeah, it's just that I don't like. I don't generally keep ABS slurry around too much.
It's a mess. I mean,
yeah.
So what ABS slurry is you spread this on your build plate and then let it dry. And what it's contained of is you get a little acetone and a lot of extra ABS and dissolve it into it, so you have a high concentration of that ABS dissolved into the acetone, and then you spread it evenly across your build surface. So now you're sticking ABS to your build surface. And now when you go to print on it, you kind of like activate a little bit of your build surface when you're printing on the ABS, so it helps it stick. Now, it is a mess, and again, with I'm going to parrot what Doug was saying over here. It is a mess, and it's kind of gunky, but I've had really good success with that. But you can make it yourself, and then what do you do with after? You got it hanging out, and people don't want to know it hanging out. Maybe they do, maybe they don't. But if you got extra ABS laying around doing nothing, which it sounds like you probably do for failed prints, just a guess. Get you some acetone, dissolve. I say use as little acetone as you have to dissolve as much ABS into as you can, and it's stay liquid. And then spread it on the thing, but you gotta let it dry before you start printing on it. You gotta let it dry before it does that.
How do you get an even thickness of this slurry? I mean, I presume it can't be too high and low in spots, right? It has to be pretty flat, doesn't it?
Yeah, it's called a paint scraper or a paint thing. You put putty on the wall, get one nice and wide, spray it on there, and drag it across.
Yeah, that's why I think if you can get this glue stick to work for you, it's a lot easier.
Yeah, I'm going to say give them all a try.
We were able to get a very we were able to get a very runny slurry working that basically just patted on with a sponge, and it's very, very thin, and it worked just as well as the thicker stuff. So I only use the thicker stuff when I want to glue ABS parts together. So we kept different wetnesses of slurry basically for different purposes.
Okay, what is it called when it's not support, it's kind of you do a print that's very flat, that surrounds the part?
Skirt, right? Or a
raft or a
raft,
brim?
yeah.
You do it.
Or a brim?
I think it's a brim.
Brim,
I think you're suggesting.
Brim is directly on and attached to the print, and that's always a good thing, right?
No, that's a raft. That's a raft.
A raft
is like a waffle.
Yeah, you'll build a whole layer out of stuff, and then you print on top of that layer.
Yeah.
I'm assuming you guys use or print with either rafts or brims, or
I always do with a brim, but never with a raft, unless I'm trying to make a 15 centimeter by half centimeter column. Then you need a raft, because you can't support it. It's too tall. It'll somewhere along the line it'll fail. But I try also to avoid. I don't want to print cylinders, and I don't want to print flat plates. I mean, I do, but the reason why is because I can have other materials that are flat plates, and there's always dowels or aluminum, tube. You know what I'm saying? I just don't prefer to have a 3D printed tall cylinder flagpole type thing.
Yeah, I normally print with skirt. So the skirt is just lines around the full print that you're about to do. So you can tell whether or not you're getting a good, nice, even flow of plastic.
Yes.
Because if it's squirty or something, I guarantee you, as soon as you try to print your real part with it, all that squirty is going to go on your real part, and that's not going to work either. So that's why I'm doing that. And
what did you call that, Harold?
A skirt.
Okay, well, I guess what I'm calling a brim is really a skirt, because I only do it on the first layer. But I will say that there's another trick that's really cool. If you don't have automatic bed leveling, you can use the skirt the one time around. Instead of just going around your print, you go a big square around it. And what that gives you is you can look at the width of the deposited first layer, And if it gets too squished, you know that part is too high. That part of the bed's too high. And if it goes to where it's just like a bead, then you know that part of the
too low
of the bed is too low. Okay, what you want is a nice even, like squished line, but not smashed line. I don't know. I know that's kind of a bad term, but
I do that too, Doug. Because I can tell by eye when that thing starts to go. I've got a CR touch now, so I don't worry about it too much. But I can tell by eye as that first couple of you can do it with brim too. Brim is actually just flat and attached to the print. Skirt is actually 2 or 3 millimeters off the print.
Yeah, all I was talking about was a skirt. I don't use a brim. I use a skirt.
I got you. And but I do that same technique when I have a printer that doesn't have a way to do auto bed leveling. Is you sit there and just watch it, and after you practice it a few times and see some good successes, you get a picture, you get something in your brain that says, "Ooh, that looks good," or "Ooh, that looks bad." You might be able to describe it, you might not be able to, but you could certainly get to fill out your printer and go, "Ooh, that's too squished," like Doug was saying. I'm going to back that off, or that's not squished enough. I'm gonna let that. I'm gonna do it so I rise up a little bit on the corner, and you can do that literally on the fly as it goes, and you get pretty good at it once you try it. It seems hard, and the first times you're going to screw it up. But
the one is if you're working with a glass plate, that can if you get it too high, the bed too high, you'll actually chip the glass. So you have to be kind of careful there. But like Harold said, is after you've seen a couple of prints, you know exactly what the sweet spot is, and it's amazing. Float glass is one of the flattest things you can buy, but unfortunately, when you lay it on top of a piece of aluminum and the aluminum is warped, you can often find on a lot of 3D beds that they got dips in the middle. I mean, that really can make things tough if your thing's not flat. Anyway, those are all little tricks. Yeah.
Doug, is your Malon 150 still working?
Oh yeah, I use them. I use them all the time. I was making some sensor. I was thinking on my new on Club Robot of adding two of those Pololu lidars, one on each side. And I was thinking about doing that. So I was playing with it.
Why two? Oh, it's not a rotating lidar.
Yeah. No, yeah. This is just one to look out both sides. I also wanted to put one at 45 degrees, but I don't know if I'll get that in 2 weeks. You know how it is. You start looking at your robot and you say, if it had this, it would really be cool. And the next thing you know, you're in a rabbit hole. So I was trying to maybe stay away from the rabbit hole. This is cool.
Oh, did you get those sensors when they had them on for like, I don't know, just under $10? You could get 3 for under 10.
No, I don't think I saw that. No.
Oh, yeah.
I think I got them when they first came out. So most of the ones I had were deeply discounted, but they weren't. I don't think I got 3 for 10. I think I probably got them for $4 to $5.
Okay.
Yeah.
Yeah, I think, God, they're like almost $20 each if we're talking about the same ones. They have like an RC pulse width that's continuous output. Are those the ones that you were getting?
The one I was getting, I don't know if it's RC. I guess it is.
It's an RC like pulse width.
Yeah, it's continuous. The length of the pulse tells you how with the distance, if I remember.
Right.
Yeah, and they have one that's got a really good range and maintains its sample rate. To me, there was one sweet spot sensor in their offerings. and I went for that one.
Yeah, I'm looking at the Palula website. They have the digital distance sensors for $9.95 each.
Ooh. Yeah, I got them considerably cheaper than that.
Yeah, when they first came out or something.
Yeah.
Yeah.
Mm-hmm.
Well, I'm really happy with my goal sensor when I got an extra HCO4 and pointed it straight up.
Mm-hmm.
Just all of a sudden, all my problems of goal sensing went away.
Yeah.
Yep.
Yep. Yep.
It'll work.
Yeah. So there's one that just tells you, some of those, Ray, will just tell you that you have seen something.
Right.
Those
I got the one that's.
I didn't see those as being very valuable. The
ones
ones
I got the ones that it puts out a pulse width proportional to the distance.
Mm-hmm. Can you tell me what's the big range? What's the best range?
I got the ones that are 300. I want to say 300 centimeters. It's like 3 meters.
Yeah. Okay. That sounds about like the ones I got.
Specials. This one. Yeah, 300 centimeters or 3 meters. It's the number 4079. And it looks like it's good between, looks like 4 centimeters and at most 300 centimeters, which is pretty good. And normally they're like, well, now they're like $17.95, but with the special, they're $9.95, I think. Okay,
I did not get the 7.9s. I don't think. I think I got the 7.1. So I was 130 centimeters and 100 megahertz update rate. But you can make any of these sensors, any of the other sensors, by moving a couple of resistors,
jumpers around.
Jumpers around. So you can make them any one you want. So, you know.
Yeah. Yep.
You just pick the one that you like and use it.
Yep. Yeah, I was kind of experimenting with them. I think your SAS formula for side angle side to find the third side was really what I needed. I sounded like you had looked at that maybe before and came across it, or
no, that I don't remember much from my high school trig, but side angle side was one of the things that stuck with me, because they used to make us do these problems where we had to find all the angles and all of the side lengths, and there were several. It's not the only one. For example, I think if you know the angle and the opposite side, you can do it too. There's 3 or 4 of those rules. Side angle side is just the only one I really remember.
One that stuck into my brain from my geometry teacher, because I remember doing those proofs as well.
Yeah,
there, Doug did a lot of them. He says the teacher always said, if it spells a dirty word, that's not a valid thing. So ASS is not a valid deal. So side angle side is angle side angle. You know, those kind of things are okay, but if it's a dirty word, it's not usable. It's not
sports.
And I don't know why that stuck with me. Maybe because it made me laugh. But but if you think about it, I've got an angle, a side, and another side over here. You got this thing waving out in the wind here, and there's no way to tell. But an angle, side, and an angle, you have it, or a side angle and a side, you've got some definition there, right? You got something placing things.
Yeah. Anyway, the other thing that I figured out is if you only have one of those sensors that we were just talking about, you do a reading, move a certain distance, say 10 centimeters forward, take another reading, you can tell whether you're aligned to a sidewall or not. Pretty easy.
Say that again.
Okay, so if you can do it one of 2 ways. On the side of your robot,
yeah,
if you have one sensor and you move forward, like say 10 centimeters, some fixed amount,
Okay.
you can figure out, what your angle is to a sidewall.
Yeah, because you have, I'd
It's
have to go through it, but that's, I think I see where you're going with that. That's kind of cool.
Yeah. So the other
Kinda cool,
approach
right?
is that you can have two of those sensors, say a fixed distance, say 10 centimeters apart on the side of your robot. Of course, you'd have to, I think they would probably interfere that close because the beam angle is like 15 degrees. So I don't know if it would screw up the readings between, if you had
Well,
two.
you could pulse them at different times.
Yeah.
I think they have the ability to, I want to say they have the ability to be triggered.
Yeah.
There's a pre-running, but I think you can trigger them too.
Yeah. Well, I know there's an enable pin on it, so you could just enable one, make a measurement, enable the other one.
Yeah.
So same thing there. You can figure out from those two distances how far, or what's your angular orientation to one of the long walls is. So
Well, that's intriguing. Yeah. That would be, if you could do it with a single sensor,
yeah.
that would really be nice.
Well, the assumption there is you can move 10 centimeters. So maybe if you had one in the front, so you didn't run into a wall, you could say, okay, I'm going to see what the distance is in front of me. If I can move 10 centimeters without hitting a wall, and then move forward. Of course, there's always a gotcha. If you're that close to one of the corners, interior corners, it may screw your readings up.
Oh, yeah. Yeah.
So, but if you're, well, the one sensor that can do like 8x8 readings, you could also use one of those and not move because you have 8 readings at regular intervals across the front of it. So, and you can also use the side angle side with that to figure out.
Yeah. Well, let me ask you, have you actually, I know you've probably done it on paper, but have you done it, mounted one and seen it correct itself?
Not yet.
No, that'll be fun. That would be really interesting to see.
Yeah.
I think Mike was using. Mike, are you using your? You said it would correct it. Is it correcting because it's reading an updated magnetometer reading, or is it reading because you're getting better reads off of your? Or are you deducting your spacing from the walls with your ultrasonic on your robot?
Well, I use the navigational unit to try to maintain a heading.
Right.
But I have 2 sonars I can point to both walls, and if I get the right total distance, like the whole 7 feet, then I know where I am exactly between the 2 walls.
Okay.
And
I
do that periodically, and then when I go through a goal, I know where that wall is. So I update that every time I put a can in the goal, and so it keeps me within some bounds. Tolerance. Yeah.
Yeah. Cool.
Yeah. One of the other things, and I've never used odometry, probably like everyone else has used odometry. But I wanted to get into it this time to see if I could use it fast enough. And one of the other things, like if you are doing it with a camera, with just one target at a fixed height at the end of the goal, the Y centroid tells you how far you are, because the closer you get to that color blob or the flag or whatever you want to call it, marker, the angle gets steeper and steeper, because it's kind of like this thing's up here and you're seeing it at a sharper and sharper angle until it's not quite vertical, but because you can put it like 3 feet in behind the goal, just as long as it's in the keep out zone.
Yeah.
So that's another thing that you can use to say, okay, I am so many feet away from the goal, and it's fast. It's as fast as your frame rate of your camera, and it, even though you're looking at it at different angles, it as you get closer and closer to it, it may perceive the width as changing because you're getting closer and closer to it. So. But the height doesn't seem to change. So the centroid in the Y direction always seems, that seems to be a reliable thing. So I was looking at that and then using a sensor, one of the ones that we were just talking about, to say, okay, am I parallel to a wall or 3.5 feet over, where, I'm in the center of the pointing at the center of the goal. So, and that's why I haven't made any progress, because I've been investigating all these things. It's like, ooh, but wait, what's this?
Yeah. Well, I'm gonna be real curious here, so we'll see how it goes. Yep. Okay. Yeah, I know I'm still struggling through my old code base, but I'm optimistic. So we'll see how it goes.
Yeah, I think I've changed everything I could possibly change. Different camera, different processor, different motor driver, different motors, different wheels, different frame.
Well, I got down to Micro Center the other day, and I even got, they give you a freebie. In my case, they gave me a free 128 gig flash card. So, I go down there, but I always say, well, I'm just going to go into the line. I'm just going to get the flash card and leave. And it didn't happen. I ended up buying something else. So they were successful. You
go all the trouble of driving there. You got to look around.
Yeah, and there's always something, Doug, that you want too.
Oh, for sure.
Not that you need, because you didn't need it before you went in, but you sure do need it when you see it.
Yeah,
my limit is,
I don't do man shopping.
My wife imposes a half-hour limit at Micro Center, and beyond that, she may leave me there.
It's a long walk home for you, isn't it, Ray?
It is. I tell you, be an expensive, Uber fare or whatever.
Yeah. Well,
I've got a question.
Yeah.
Right, go ahead.
Who was
it? I have a question if there's time.
Sure.
I'm curious as to what is everybody using, let's say for a 6-can competition or a 6-can competition for a processor on the robot. So is everybody at the Arduino stage, a Teensy, or Raspberry Pi?
ESP32?
ESP32?
Yeah, I don't know about, I think Mike is using some advanced nano, some ARM-based nano.
Yeah, Arduino Nano. Yeah.
Yeah, and I'm just using the old-fashioned Mega. I plan to upgrade. This will be the last time that Mega will be used. I shouldn't say the last time, but I've got a Teensy to replace it. I'm just going to. It's just a question of whether or not when I'll get time to do it. Because the reason I really wanted to go to the Teensy was because I wanted the additional serial ports. So.
But how about camera? Those take a lot of power, don't they? Processing.
Well, no, actually, in my case, I'm using this right now. The one that's on there right now is a Pixie, and it talks with SPI interface to a small Arduino Pro Mini, and on the Pro Mini, there's the program that says, okay, you told me this means that what I want is over there, and then it sends one character over a serial port to my main board, which tells me whether I'm to the left or the right. and which way to go. And it also gives a magnitude of how far to the left or the right you are. But it's all done with one character. So.
Yep. As far as power on OpenMVH7, that's this little guy. 5 volts, about 123 milliamps.
Cool.
So not that much.
Yeah. Well, my Arduino is 75 megahertz, and I run multi-thread, like one thread for the IMU and another thread for the Bluetooth, and then the main thread.
Mm-hmm.
Yeah.
How many cores are on this?
One.
Just a single core, and you're just running multi-threading.
Right.
Just to do like time sharing.
Right.
Okay.
So it needs a lot of CPU.
I've been using a Raspberry Pi on a lot of them, but I'm thinking about switching to like an ESP32. And so I'm thinking about using an ESP32 with the Wi-Fi to use for troubleshooting.
Mm-hmm.
So have something like Node-RED where you can, spit out some data and watch what's going on.
Yeah, that's very helpful. In my case, I generally use, because I got them as prizes from the club, I use Wixels, okay, which are kind of like Bluetooth. They're not Bluetooth, but they're kind of like Bluetooth, about the same performance. So, I can transfer. I think I might go if, I want to have something like what Ray has on his chick magnet.
Yep.
So I want to be able to have something for November where, I can use teleop. I can just look at it and see what's going on. Well, I guess that's not tele. I want to have data transferred to off board so that I can kind of watch what's going on.
That's why I'm sort of looking as well to see like using an ESP32.
I think that's a good selection, especially if you already have a Raspberry Pi on your robot.
Yeah, well, I'm thinking about eliminating the Raspberry Pi.
Okay, so you're going to have two if you're going to have one offline. Otherwise,
well,
one will be on your
a laptop for the other one. So by Wi-Fi, I'd be able to connect to.
Okay, well, if you're going that way, why wouldn't you just, buy okay, well, I mean, a laptop's more flexible, I guess, but don't you? I'd want to have something I can carry around with me.
Well, you can carry around a tablet, or I've got a little Chromebook.
Oh, okay.
So that's what I was thinking. So.
Well, Ray's probably got the best experience on that.
Who's that?
Ray's probably got the best experience on that. He's actually gone there at least once.
Oh, what are you talking about? The ESP now? That's what I use. This is it's got an ESP32 in it. It's got a capacitive touch screen. Basically, you can, with ESP now, this is my chick magnet.
It's getting better. It's getting better.
And it basically, the text is big enough and bright enough that I can see it outdoors, and I don't have to stare at this little
can you
TV
see it in
screen
full sunlight?
on the robot. What's that?
Can you see it in full sunlight?
Yeah, if I shade my,
Okay.
I can see it like this, and it's fine. But yeah, it's bright enough in sunlight.
It kind of needs that for his robot. Yeah, to control it.
I could, I don't. It's one way. You can do with this ESP now. You can have one transmitter to one receiver, one transmitter to multiple receivers, multiple transmitters to one receiver. It's very easy to set up. You basically just send a structure with all of your data. There's not limitations on, you can send ints, floats, you name it, characters, whatever you want to send. And it's, I think this is I want to say a 480 by, well, no, this one may actually be an 800 by 480. I forget which. I think it's an 800 by 480. But, you can get enough text on it that pretty much any parameter that you want to see, you can see. And it just made it a lot easier to debug things, looking at this versus, trying to set up some other method of seeing what the platform was doing. I think this is I want to say it's the WT32-SC01. And I think pretty certain they still sell, this is the older version. There's a newer version, but I kind of preferred the older version.
Mm-hmm. And that's called, what is it called then?
The number of it is if you're looking it up like on AliExpress, it's a WT32-SC.
Wait a minute, WT or
yeah.
P?
T is in Tom.
32.
Yeah. Dash SC01.
Okay.
And it's it just made it a lot easier, like I said, to look at that as your platform's moving along. And I could update things like 20 times a second, to see, like one of the things I was watching was the angle and the number of meters to go to the target, as that decreased. And I actually changed speed as I approached the thing, the cone. And I knew when I got into that, it was supposed to be a meter away from the cone, it would actually slow down so the camera could find the cone, and then it would use the camera to guide it, because you had to touch the cone. So
yeah. Oh, I don't know if I mentioned this, but I think I did. That the Seattle Society of Robotics Society, it's SR, yeah, is going to actually be, I think it's running in September. And so if anybody's ready, I'm not going to be ready, but they've got it set up where there are some tasks that would be pretty easy to do. They have one which is basically an out and back, and then they have one which is a big square, and then they have their classic Robo Magellan. So anyway, it might be fun, maybe not this year, but if we could get a couple of robots that would really do it, maybe just actually travel out there and see if we could win something. So they're pretty tough. They have some pretty talented people out there. Yeah. Yeah.
So Ray, on your WT32, you're sending what type of signal to what type of unit?
Yeah, it's using it's just called ESP now. It's I guess close to I think it's either 2.5 gig or 2.4 gig. It's the lower Wi-Fi frequency. I guess it's the older one. The newer ones are more like 5 or something gig. Anyway, there's an excellent tutorial on randomnerdtutorials.com. Cool. He tells you how to set it up. And it's just search for ESP now, and he's got it. I think he's got it for both the 8266 and the ESP32. And so basically you create a structure of all the things that you want to send. And like I said, it could be any combination of whatever your variables are, ints, characters, floats, longs. And you basically load up the values in this structure and send it, and it's sent, very quickly. I used to know how long it took. It's in the, under, I want to say it's under 100 microseconds. It's very quick, and you're limited to 250 bytes total on the protocol. But 250 bytes is a fair amount of information. And, you decide how you want it displayed on the LCD, where you want your labels and the values. And
yeah, is that basically, are you actually on your screen? Or are you just projecting a web page?
Nope. It's just, it uses the Adafruit graphics library.
Yeah.
And it's just text.
Okay.
So you can do more sophisticated things, like you can use widgets if you want. You can do plots if you want. But for just, looking at.
But that doesn't count against your 256. That's something else.
Yeah.
256 is just a payload that you're sending over.
That's right. Yeah.
Okay.
Yeah. So, but.
So you have to have two ESP32s.
Yes.
One on the robot and one on the one. That's cool.
Yeah. There is one in the WT32.
Yeah. So that's Pat. That's another good reason to maybe go to an ESP32.
Yeah.
Makes that sort of functionality very useful. I mean, you don't have to, obviously, but you could, because you could you could ping pong it. Otherwise your main processor could send the ESP32 the payload, and then it could transfer the payload out to the chick magnet. So, yeah.
Yeah.
So,
this is another one that this is actually an ESP32-3248S035. It's similar to the WT32. It's got this one is definitely 480 by 320, because that's in the part number.
mm-hmm.
That's the 3248. But it also has an ESP32 on it. This one has less interconnect. The WT32 has two 40-pin connectors on it. This one, I think, has got, I want to say they're Grove connectors.
Yeah, I think I've got one of those, Ray, because I think we were talking about it, and I went ahead and ordered one.
These were like $15, I think.
They weren't very expensive.
Yeah, and for what you get, I mean, it's a really nice display. It's capacitive touch.
It also has a SD card, I believe, on it too.
Yeah, this one does.
So you could actually record your readings and look at it again afterwards if you wanted to.
Yep. Yeah. So there's a bunch of, I don't know, I think really cheap options, for LCDs like that or that board from a U.S. manufacturer. I'm guessing would cost at least $100, not $15.
Yeah.
So there's a lot of options out there for that kind of stuff. But
I had another question as well. I put in the chat. Did anyone order back the Kickstarter ArduCam SPI?
Yes.
Have you received it?
That's the one that's supposed to be the universal SPI spy interface camera.
Yeah.
Yeah. I bought the very basic, whatever it was.
I bought a 3 megapixel, but I have not received notice that it's shipped yet.
Me neither. And supposedly they said they were shipping out like 80%. And
Yeah, I thought it was above 80% they had shipped out, and it was expected in April.
Well, the thing they said was that what was holding people back was their phone number. But you know what? I know I sent them my phone number.
Yeah,
so.
I confirmed it as well a couple of weeks ago, and still nothing.
Yeah, so.
Did you include like the 001 in front for the,
I'm
no,
pretty sure I had,
US code.
pretty sure I had the one. It's the same as the US, one in the area code. And,
yeah.
Yeah. So. Yeah, I just have to. I would like, if you get one, send me a message, Pat, and I'll send you a message and say, hey, I got it or not. But
okay.
But right now, I haven't. Usually they send you a message saying, "Happy day, here it's coming. You should see it. It's in the mail." I haven't got that one yet.
Yeah, exactly. I did get that one for the 3D one. The time of flight.
Yeah.
Not 3D, but the time of flight, and then but I haven't seen anything in the STI one.
Yeah. Has anybody else seen any interesting Kickstarters recently? I don't think I've seen any. I haven't. Other than that was probably the last one I threw some money at.
I have several I've thrown money at, and I haven't really. It looks like they started to deliver while I was out, so I got to pick them up.
Yeah.
The coolest one I should share because it came in and I put it to use, and it's just phenomenal. So let me try and pull it up and show you because it's pricier than I'll get out, but it's an awesome tool. It's loading slowly here. Here we go. Here we go. Yeah, this thing. It's not really a microelectronics tool by any stretch, but check this out. This thing, basically it's a ratcheting driver, and it comes with some adapters, so you can use any number of different bits and things with it. But this arm folds down, and they've apparently tested it. It has about as much torque as some old VW bug or something.
Oh.
So it's much more than you could ever apply. But it's just really
okay. So it's bigger than I thought it was.
Oh, it's huge. I mean, did you see that? He had a like a 1-inch hole bit in drilling through like that.
Yeah.
So it's a torquey beast. But it is solid. It's got a really nice industrial design. Just like to look at it.
That looks nice.
Yeah. So that one came in. I have to say I was pleased.
Yeah. It's really cool when you get one. That's probably like how I felt when the OD lights came in. This was really cool. They actually done something neat.
Yeah.
Yeah.
Yeah, and they have a. Anyhow, they have an upgraded bit in the middle. Like the first one came with aluminum here and a hollow aluminum handle. But then you could get the aluminum handle where it has a storage for spare bits, and you could upgrade this middle piece to steel, which I did. So it's even more torquey.
Mm-hmm.
So
yeah.
Good for rusty bolts on an old Mercedes, maybe.
That's how I'm thinking about it. That's where it lives now. Actually, I sheared the first rusty bolt with it. So
oh no,
a sheet metal screw. I have the head in one of my hand, and the rest of the shank is in the car. So, But this company's pretty cool. They go and find long expired patents.
Yeah,
and then they remake the stuff with modern materials and updated industrial design. So this is my second or third that I've done with them. And I guess these guys used to design parts for nuclear submarines, and they said, to hell with this. And they said, I'm just going to do cool stuff. So that's what they do now. Anyhow.
Yeah, this is a pretty cool one. It's a, let me see what the current is. I'll stick a little meter on it. Okay, let's see what it says here.
I don't know. Designing stuff for nuclear submarines, it could be pretty cool.
Well, it could be, but you're working for the boss, right? These people are just doing whatever they feel like.
Okay, this is a 100 by 100. It's like a time of flight camera. 100 pixels by 100 pixels. It's drawing 150 milliamps. You can reduce it down to like 50 by 50 or 25 by 25. And it's good for this one. I want to say 2 meters. I'd have to look it up. But I don't know if you can see my outline of my silhouette kind of on the
Yeah, I can see it.
But or if I,
what is the name of this? Because I think I have some of these.
Oh, it's a Max. It's from Cypede. It's a Max or Makes Sense A010.
No, I don't have one of those.
You've shared this a few meetings ago, or
yeah,
months ago. Yeah,
another one of those toys I haven't played with yet. So
yeah,
but,
there was somebody. There was a similar product that came out on Kickstarter. What was the name of that? I went and actually got a couple of them.
Oh, you did?
Yeah. Yeah, it was
anyway,
made by the same people that I think did Oak D. So I'll have to anyway. But it was real little like that. You know, it wasn't. The problem I have with it is, okay, it's got all the data in it, but how do you get hold of the data? You know, it's fun to look at it, but yeah.
You can either do it through, USB. There is a serial port on it. You can get data at, I think, whatever that high data rate is. It's like 900,000, 921 something. I forget what the actual baud rate is. I've never used it that high. So you can say, max resolution is 100 by 100. Like I said, you can go down to 50 by 50 or 25 by 25. And even at 25 by 25, it's 625 pixels that are blocks that you're looking at for distances. So I'm thinking for the most part, I may just want to look at a line of pixels to say, do I see, like the gap of the goal or the two sides of the goal? So it's kind of, in a way, it's TMI, you don't need that much information to find where the goal is. So, but that was pretty cool and cheaper than all the other ones that I've seen. I think it was less than $30. So
cool.
But anyway, so right now, it's drawn 100 milliamps now. So not much. Anyway, so many toys, so little time.
Yeah. Well, guys, I'm going to have to drop off. It's 10 o'clock now.
Yep.
So I think we're going to just adios here. Hey, guys.
Sunday?
See you Sunday or Tuesday online.
Yep. Bye-bye.